Okay, here is the answer key for the second practice test. Now this is not meant to be super hard, confidence builder perhaps, and you'll see I'm going to do this sort of in real time. It should take about 10 minutes tops. Sam owns 6 pairs of pants, 5 shirts, and 3 pairs of shoes. How many different outfits? This is just counting by filling in the blanks. You've got 3 options, 6 for the pants, 5 for the shirts, and then 3 pairs of shoes. You just are going to multiply those. 6 times 5 is 30, times 3 is 90 different outfits. Just use that fill in the blank method whenever you're in doubt. Pretty reliable. What is the probability of choosing 3 black marbles all at once? That's no different than taking 1 at a time and then winding up with 3. Out of a bag that contains 10 black marbles and 6 red marbles. There are 10 black marbles out of a total of 16. That's 10 plus 6. So the chance of choosing a black marble, just the fact that I'm choosing 3 of them, don't get confused. Some people will write like 3 out of 10 because they'll say you want 3 black marbles and there are 10 of them there. But it doesn't work that way. The probability of choosing the first black marble is that there are 10 black ones out of a total of 16. Once you've chosen that one, the chance of choosing another one is now 9 out of 15, and then 8 out of 14. Without using a calculator here, you can cancel the 10 and the 15 and write a 2 and a 3. Cancel the 8 and the 16 and write a 2, and then these 2's cancel. 9 and 3 cancels with a 3, and I get 3 out of 14. That is the final answer, 3 out of 14. Of course, you can type it in your calculator and have it simplify, but that's a good thing to know how to do. Choosing a card from a 52 card deck with ace, which is a 1, through 10, and then going into the face cards, jack, queen, king. Chance of choosing a card that's a multiple of 5, well, that's only a 5 and a 10. There are 2 of those per 4 suits, so you could say right off the bat it's 2 out of 13, but you could also just say, well, that's going to be 8 out of 52 total. That's our definition of probability. There are 8 cards out of a total of 52. Simplify it down to 2 out of 13. You can write that as a percent, but that's really easy to see the exact fraction. Choosing a card that is a king or a queen from a deck of cards, well, that's kind of boring. It's the same deal. 2 options per suit, so same exact answer. I will try to give you a little bit more variety on the real test, but it just happened that that was a little bit dull. Are these 2 things mutually exclusive? Well, ask yourself, is there any multiple of 5 that's a king or a queen? And we don't keep counting, and even if we did, it wouldn't work. So that is yes, they are mutually exclusive. There is no overlap. And you'd say, well, there's no 5 or a 10 that'll ever be a king or queen. No overlap. But don't just write that no matter what I ask. So it's sort of explain, but I'm saving time here. You could say a 5 and a 10 is not equal to a, what is it, a king or queen. Are A and B complementary events? Do these 2 options add up to all the cards in the deck? And that is a heck no. Not whole, I'd say 5 and 10 plus king and queen, not whole deck. Complementary events have to combine to make the whole, all of the possible outcomes. How many passwords can be made from the first 13 letters of the alphabet? Well, that's, it looks like the assumption is you have all 13 letters, so that's just 13 factorial. Call that part A. If I had wanted there to be 5-letter password, then you would be saying it's 13P5. Think of password with P. Order does matter in a password, so that would be a different answer, but this is the one correct answer. You can try that as a bonus one and figure it out on your own. What's the oops, I'm going off the screen, sorry. Bring this back into the screen. I hope you saw that. That just simply is 13 factorial. What is the probability of tossing 11 coins and having 7 of them land heads? Shortcut answer is that it's just going to be 11C7 over 2 to the 11th. If you think about it, you can do the fill in the blank method like we did in 6-8, where you say, well, what's the probability of getting a head? That's 1/2. How many heads am I going to have? 7. What's the probability of the other thing happening? Well, a tail. That happens to be the same in this simple one, and I would have 4 of those, and then it's times 11C4 or 7. They'll be the same. When you plug that all in, you're going to get a decimal that's about 161, and that's approximately equal to 16.1%. That's a good way to answer that. And then finally write a minus 1 to the 6 in expanded form. Go to the 6th row of Pascal's triangle, look that up. I think it's going to be 1, 6, and then, oh my goodness, I'm forgetting 1, 5, 10, 10, 5, 1. So that's 15, 20, and then 15, 6, and 1. So starting with those numbers, then it's going to be 1a to the 6th, and then 6a to the 5th, and then 15a to the 4th, 20a to the 3rd, and then 15a squared, and then 6a, and then using the negative 1, it's going to be then negative 1 to the 6th, and negative 1 to the 5th, and again negative 1 to the 4th. You count down going the other direction, negative 1 to the 3rd, negative 1 squared, and then negative 1. The final thing we have to do then is put the plus signs in and tidy it all up. Make sure you work in the negative sign as it should be done. We can start at this end. Negative 1 to an even power is going to be just a plus 1. And then 6a to the negative 1 to an odd number is going to be negative 6a. And then again it's even, so that just drops out, 15a squared. This is an odd number, so that'll be odd, minus 20, that'll be negative, minus 20a to the 3rd. And this is an even, negative 1 squared will be back to positive again, so it's just 15a to the 4th. This is your 1 negative sign, so this is going to be a negative 6a to the 5th, and then a to the 6th. So that is the final answer where it is all cleaned up. Alright, that's it.